Good morning, students. Myself Dr. Devendraya, working as a lecturer in Virshava Degree College, Ballari. Today we discuss the concept generating function for Legendre polynomials. Let us see, define the generating function of Legendre polynomial Pn of x and prove that 1 minus 2xz plus z square to the power minus 1 divided by 2, which is equals to summation of n is equals to 0 to infinity z to the power n into Pn of x when mod x is less than or equals to 1 and mod z less than 1. Further, reduce the recurrence formula n plus 1 into Pn plus 1 of x minus 2n plus 1 into Pn of x plus n into Pn minus 1 of x, which is equals to 0. Here suppose the question is define the generating function. The function 1 minus 2xz plus z square to the power minus half is called the generating function for Legendre polynomial Pn of x, and its value 1 minus 2xz plus z square to the power minus 1 by 2, which is equals to summation of n is equals to 0 to infinity z to the power n into Pn of x when mod x is less than or equals to 1 and mod z less than 1. So let us prove the proof of the generating function. So we assume that u as 2xz minus of z square. So therefore let u is equals to 2xz minus of z square. Taking z as common factor, we observe z into 2x minus z. Replacing the value here, consider 1 minus b to the power minus half. It is in the form of the binomial expansion 1 minus x to the power n, and we know the expansion of binomial theorem that the term can be written in this format 1 minus nx plus n into n minus 1 divided by 2 factorial into x square minus n into n minus 1 into n minus 2 divided by 3 factorial into x cube plus etc. Here 1 minus v to the power minus half. In place of n, we observe the value as minus of half, and we expand by using this 1 plus half into v plus half into 3 by 2 divided by 2 factorial into v square. Similarly, the third term is 1 by 2 into 3 by 2 into 5 by 2 divided by 3 factorial into v square plus etc. etc. Since the n value here is minus half minus 1 will be minus 3 by 2. Minus 3 by 2 into minus will become so plus 3 divided by 2. Therefore, we write half into 3 divided by 2. Here n minus 1 once again minus 3 by 2 minus 5 by 2. Okay, therefore the term takes the form of 1 by 2 into 3 by 2 into 5 by 2 divided by 3 factorial into v square. So this is the expansion we have considered by using binomial theorem. Similarly, we write this value half into v as 2 factorial divided by 1 factorial whole square into 2 square. To get the equation in the standard form, we are writing half into v as 2 factorial divided by 1 factorial into 2 square. Its value will be half itself. Similarly, so 2 factorial followed by 4 factorial followed by 6 factorial. Similarly, observe the denominator 1 factorial whole square. We will write 2 factorial whole square. So into 2 to the power 4, 3 factorial whole square into 2 to the power 6. So this is the this term is the value of this. So to write the equation in the standard form, so we are writing the terms as 1 plus 2 factorial divided by 1 factorial whole square into 2 square into v plus 4 factorial divided by 2 factorial whole square into 2 to the power 4 into v square plus 6 factorial divided by 3 factorial whole square into 2 to the power 6 into v cube plus etc. etc. Now replacing the value of v as z into 2x minus of z. So therefore we replace the value here as z into 2x minus of z to the power minus 1 divided by 2. Okay, towards here in place of v we replace the value as z into 2x minus z to the power minus 1 by 2, which is equals to 1 plus 2 factorial divided by 1 factorial whole square into 2 square. We replace the value of v as z into 2x minus z. Here also z square into 2x minus z whole square, like that. For the term n minus r, we write the value as 2x minus z to the power n minus r into z to the power n minus r. For the term n, z to the power n into 2x minus z to the power n. We replace the value of v as z into 2x minus z. And we consider that as equation 1. Now we shall collect the terms containing z to the power n from the term containing z to the power n minus r into 2x minus z to the power n minus r. Remember this point. We shall collect the terms containing z to the power n from the term containing z to the power n minus r into 2x minus z to the power n minus r. That is, the term containing z to the power n minus r is 2n minus 2r factorial divided by n minus r factorial whole square into 2 to the power 2n minus 2r into z to the power n minus r into 2x minus z to the power n minus r. Here, so we observe the term containing z to the power n minus of r into 2x minus z to the power n minus r will be 2n minus 2r factorial whole divided by n minus r factorial whole square into 2 to the power 2n minus 2r. That is the term we are considering here. That term we write as 2n minus 2r factorial divided by n minus r factorial whole square into 2 to the power 2n minus 2r into z to the power n minus r into, we write 2x minus z to the power n minus r as n minus r cr into 2x to the power n minus 2. This I will explain later. So let us prove the proof. So which can be written as 2n minus 2r factorial divided by n minus r factorial whole square into 2 to the power 2n minus 2r. Writing the value of ncr as n factorial divided by n minus r factorial into r factorial. In place of n, here we observe as n minus r factorial divided by r factorial into n minus 2r factorial. And so writing z to the power n minus r in this format, minus 1 to the power r into z to the power n into 2x to the power n minus 2r. Now cancelling the term n minus r factorial, n minus r factorial. So we observe the value as minus 1 to the power r 2n minus 2r factorial into x to the power 2n x to the power n minus 2r. Here we have 2 to the power n minus 2r. So here we have 2 to the power 2n minus 2r, and the term will become 2 to the power n because of bases are same. So we observe the value as 2 to the power n. R factorial write as it is. and 1 n minus r factorial write as it is, remaining term n minus 2r factorial write as it is, into x to the power n minus 2r into z to the power n. So this is nothing but the terms containing z to the power n minus r will be minus 1 to the power r into 2n minus 2r factorial divided by 2 to the power n into r factorial into n minus r factorial into n minus 2r factorial into x to the power n minus 2r. Now similarly, the terms containing z to the power n in z to the power n is 2n factorial divided by n factorial whole square into 2 to the power 2n into z to the power n into 2x minus z to the power n is given by 2n factorial divided by 2 to the power n into n factorial into n factorial into x to the power n into z to the power n. Observe the equation 1, we observe this. Thus, the coefficient of z to the power n in the expansion of 1 minus 2xz plus z square to the power half is given by Pn of x, which is equals to summation of r is equals to 0 to capital M minus 1 to the power r. So we are writing this term because z to the power n will be, coefficient of z to the power n will be minus 1 to the power r into 2n minus 2r factorial divided by 2 to the power n into r factorial into n minus r factorial into n minus 2r factorial into x to the power n minus 2r, where capital value of capital M value will be n divided by 2 if n is even, and n minus 1 divided by 2 if n is odd. This we have already observed. Thus we have 1 minus 2xz plus z square to the power minus 1 by 2. This value will be equals to summation of r is n is equals to 0 to infinity, and we know that this term can be considered as Pn of x into z to the power n. Now to reduce, this is the method of proving recurrence formula. Now to reduce the recurrence formula, so let us consider this as equation 2. Differentiating 2 partially with respect to z, we get minus half into 1 minus 2xz plus z square to the power minus of minus 1 will be minus 3 by 2. Inner derivative of this term will be minus 2x plus 2z, which is equals to summation of n is equals to 0 to infinity Pn of x into, so when we differentiate with respect to z, n into z to the power n minus 1. Now so taking 2 as common factor and cancelling 2, x minus z into 1 minus 2xz plus z square, writing this term minus 3 by 2 as minus half into minus of 1. So and minus 1 when we write here, so on cross multiplying it will become 1 minus 2xz plus z square. So remember the point, minus 3 by 2 can be written as minus half into minus of 1. So here minus half into to the power minus 1 we have. So any term to the power minus 1 will be 1 divided by that term on cross multiplication will takes the form of 1 minus 2xz plus z square into write the right side term. Here we have minus to the power minus 1 by 2. Now x minus z into summation of this term can be considered as summation of Pn of x into z to the power n, which is equals to, write the term as it is, n into Pn of x into z to the power n minus 1. Now equating the coefficients of z to the power n from both the sides, we get x into Pn of x minus Pn minus 1 into Pn minus 1 of x, which is equals to n plus 1 into Pn plus 1 of x minus 2n into x into Pn of x plus n plus 1 into Pn minus 1 of x. Now on collecting the terms on one side, we observe the equation as n plus 1 into Pn plus 1 of x. This is the term remaining. Now observe the terms of Pn of x. We observe the value as minus of 2n plus 1 into x into